Today's lesson is a continuation of section 4.3, graphing using intercepts. We recently learned how to graph using this method number 2, the x and y, finding the x and y intercept. We've also been working with this method the whole chapter 2, finding ordered pairs. Today we're going to kind of analyze both those methods, or look at an equation to analyze and see which method will be easier to use for that particular problem. I want us to be comfortable using either of the two methods to graph an equation. Sometimes the way equation's set up, it's easier to use method number 1, finding ordered pairs. Sometimes the way the equation's set up, it's easier to use method number 2. And I want us to be comfortable using either method where it wouldn't matter which one I use. I could still get the correct graph of the equation. So I don't want us just isolated and knowing, or any students thinking just, oh, I'm really good at method 1 but not 2. Or vice versa, whatever method. I want us to be able to teach us different methods because I want us to be comfortable using both. And sometimes one's a lot easier than the other. Or we're just creating more work for ourselves if we only can use one of the two methods. So I want us to be able to use either one fluidly. So looking at this first problem here, what I'll ask students to do today, we'll say graph the following equation. But I want you to step back and kind of look at the equation and say which method should I use? Which method would be easier for this particular problem? Should I use ordered pairs method like we've done before, plugging in 0, 1, and 2? Or should I graph using the intercepts method where I plug in 0 for x, plug in 0 for y, and find my two intercepts? Looking at this particular problem, the biggest indicator for which method to use is going to be by looking at the setup of the equation and what form it's in. I see that x and y are both on the same side of this equation, and then I have some constant on the other side of the equal sign. So in this case, I think method number 2, the one we learned yesterday, or in the previous lesson, is going to be the easier method to use. So I should plug in 0 for x, 0 for y, and find my two intercepts. Again, like I talked about, for either method, you could still make an xy table, but for in this case, with the intercepts method, what I usually do is put a 0 in both those spots because we're going to plug in 0 for x, see what we get, plug in 0 for y, see what we get, and those are going to be our two intercepts that we're going to use. So in this case, if I put in 0 for x, again, I'm going to plug that right in where the x variable is, and 10 times 0, if I put in 0 for x, 10 times 0 gives me 0. So like maybe you've seen me do before here, or you'll see me do in class. I'm just going to cross out that term, because 0 times that is going to get rid of that term. Essentially, it's going to go away. And all I have left here is this negative 8y equals 20. And if I can solve this little one-step equation, I'm going to have the y-intercept here. Divide both sides by negative 8, and I think I get negative 2.5 in this case. So that point right there is my y-intercept because it's along the y-axis. I go down 2 and about a half, and there's that point. Now return to the original problem, the original equation. Now I'm going to plug in 0 for y instead. I'm going to take 0, I take 0 and plug it in for y up here, and see what happens when I solve the rest of the problem then and try to find out what my x-intercept is. So if I put in 0 for y, 8 times 0 gives me 0. So again, that part of the equation essentially is just going to cancel out. And all I'll be left with, because I'll just write right here, is 10x equals 20. And if I solve that equation but divide both sides by 10, I get x equals 2. So my x-intercept is now 2, 0. So I go over 2, up or down 0. There's my point. I draw a line through both those points. And there's the graph of that equation, again, using intercepts method. Could I have switched it around and solved this equation for y and graphed it using method number 1? Yes, I could. And I would get the exact same graph. But using this method for this problem makes the problem a lot quicker. So I want us to be able to step back, look at a problem, analyze it, and say which method's easier, which one will get me to the answer quickest. And in this case, it's method number 2 for this. Looking at another problem here now. I've graphed the following equation. It says y equals 3x minus 4. So again, I want our students to be able to step back, and or you as a student, I want to be able to step back and look at this problem and say, well, which method should I use? Ordered pairs method, or should I use the intercepts method? This equation is y equals 3x minus 4. It's solved for y. So I want you to be able to look at it and say, oh, that looks like ordered pairs method would be a lot easier to use for this one. Because it's already, I can plug in some numbers for x very easily, get my answers out for y, and plot those points. So in this case, I'm not going to find x and y intercepts at all. Okay, I can get rid of that part. I'm still going to use the table though. I'm just going to plug in 0, 1, and 2, or any numbers really. But 0, 1, and 2 are usually just easy ones to plug in. See what I get. Those will be my 3 ordered pairs. I'll plot them and graph my line. If I put in 0, I'm going to get negative 4 in this equation. If I put in 1, I'll get -1. If I put in 2, I'll get 2. Again, these are like 3 ordered pairs right here. 0, -4, like a y-intercept because it's along the y-axis. 1, -1, 2, 2. There are my 3 points. If I graph that line, if I had gone perfectly through all 3 of them, it would look good, but I was close. But there's the graph of that equation. I could use intercepts method as well, but for this problem, this is probably the easier route to graph this equation. So I want people to understand, or students to understand, for this one I'm going to use ordered pairs method. Looking at just a couple more together. Again, looking at this problem, graph the following equation. It says -15x minus 6y equals 30. This problem, as I look at it, I see that x and y are on the same side and a constant on the other side, so I know this is in standard form. That's what this equation is in, standard form. So which method is easier to use when it's in standard form? Method number 2 is probably going to be a quicker route to the answer. I could totally use method number 1, solve this equation. I could add 15x to both sides, divide everything by -6, and I could get to the answer. But for this problem, I recommend using method number 2, finding the intercepts. So all I'm going to do then is I'm going to put in 0 for x and 0 for y, and see what I get for my solution. Remember, my solutions, those are my 2 intercepts. If I put in 0 for x, essentially this term with x is just going to cancel out because 0 times anything will be 0, it'll go away. So now I have -6y equals 30. Divide both sides by -6, and I get y equals -5. So my y-intercept is -5. 1, 2, 3, 4, 5. There's my y-intercept, down 5. Going back to the original problem. If I put in 0 for y, essentially it cancels this term out. So now all I have left is -15x equals 30. I'm going to divide both sides by -15. I'm going to get x equals -2. So there's my x-intercept, -2, 0. Plot that point right there. Now that I have 2 points, I can graph this line. It's going to look about something like that. All I need is 2 points for the line. There are my 2 points. There's the graph of that equation. Again, I think that one was a little quicker using the intercepts method. Last one I'll talk about in class today too is I'll just look at y equals 2x minus 7 and just ask students which method would they use. We won't go through the whole thing, but I just want to make sure we understand which method would be easier for this one. This equation has y by itself. It's y equals everything else on the other side of my equal sign. So it's in slope-intercept form, as we call it, or it's solved for y. So in this case, I want to use method number 1. I think that would be an easier method to solve this equation. So again, this is what I want students to do. I'll give them more work time today to work on this, but what I want to be able to do is just like we were doing with those 4 problems. Just step back and say which method is easier, and then go ahead and execute that particular method.